Good morning, good evening or good afternoon. Whenever you are watching this video, let us welcome you all to this channel, the channel that belongs to you all, future endeavors. Okay, so in the last class we were discussing about a chapter which is present in the syllabus of class 7, and it was about physical quantities and their measurements. So basically, when you are talking of physical quantities and measurements, in the previous class we have discussed about the measurement of, we have just started about the measurement of volume. We have gave a brief introduction of what volume is, and we have discussed about the mathematical formulas that we use to calculate the volume of some regular objects. Now see, all the objects do not have any regular shape. Some of the objects do have some irregular shape for which you do not have any definite formula for calculating the volume. So thus, what process can be followed in order to measure the volume of those objects which do not have any regular shape? Let us see. So let us make heading measurement of volume, measurement of volume of irregular solids. Irregular solids. We have seen that for regular solids we have some definite formula, and accordingly if we take the measurement of the either say length, breadth or height or the radius, we can calculate the volume of those particular objects. But see, when you have got some irregular solid like a stone, see, when you think of a stone, you don't have any particular shape like this. So it should be 3D. You have to imagine it a bit. If it's a stone, it is having an irregular shape, so it does not have any definite shape. Now how can you measure the volume of this particular stone? Okay, so that is a way which will help us to determine the volume of this particular stone which has no regular shape. Now let us see, how can we measure the volume of this irregular stone? Okay, now see, I think all of you have observed that when we immerse any solid object into a liquid, whenever we immerse any solid object into a liquid, what happens? You might have seen that the liquid rises a bit, the liquid level rises a bit. So we utilize this property of the liquid in order to determine the volume of these irregular substances. Just think of, so let's demonstrate this process. If you have in order to measure the volume of irregular solids, we need a beaker, a graduated beaker. So now you will be thinking, what is a graduated beaker? Okay, so let me first just clear it to you that what is a graduated beaker. Now see, it is nothing but a simple glass container, but it has certain graduations on it. Graduations means it has scales marked on it. The scale that you use to measure the length of your pencil, the length of your pencil box, have some graduations over it. The graduations are in centimeter or in millimeter, or on the other side it is in inch. Likewise, in a graduated beaker, so what is this? It's a graduated beaker. Graduated beaker. Okay, so what is this graduated beaker? Now let's see. This graduated beaker, as I have said, is a, you can consider it to be as a simple glass cylinder. The difference is that this glass cylinder have markings, as I have mentioned, have markings on them. So like this, if you can see on the glass body, it will have markings like this, 2, 3, 4, then again like this, 1, 2, 3, 4, again like this, 1, 2, 3, 4, again like this. Like this, you have markings on the glass. Okay, so this is the main feature of a graduated cylinder. Okay, so I think it is very clear to you what is a graduated cylinder. Okay, now what we do in most of the cases, in order to determine the volume of some irregular substance, we generally take water. we have to take such a liquid which does not actually react with the substance whose volume you want to determine. I repeat once again, what should be the choice of your liquid? If you think what should be the choice of your liquid, the liquid should be such that it does not react with the substance that whose volume you want to measure. So that should be your main criteria for choosing the liquid. In maximum cases, as you know, water is a very general liquid which does not react with ordinary things around you. So if you want to measure the volume of a stone, you don't need to do anything, you just take simple plain water. Now say if I say these are the markings, okay, so I can say that these markings can be in milliliter or in liter. As I mentioned, as I was discussing on the previous lecture, I think I have not mentioned about the units of volume. See, in general, the unit of volume that we use, or rather I should say the SI unit of volume is actually meter cube. So if I say volume, it's SI unit, okay, SI unit is actually meter cube, okay, meter cube, fine. SI unit of volume is meter cube. But in, see, when you have a bottle of cold drinks or a bottle of mineral water in your hand, that bottle does not show you the volume of that liquid or cold drinks in meter cube, rather it shows the volume in liter or milliliter. So besides meter cube being a SI unit, being the SI unit of volume, we can also use some other units of volume such as milliliter or liter. So I am just writing it here, other units that we can use to measure the volume. Maybe it's liter, okay, or milliliter, okay. So these units can also be used to determine the volume. Now there is a definite relationship between liter and meter cube or centimeter cube. I'll mention it later. First of all, let us understand what is the procedure. Now see, this graduated cylinder or graduated beaker, as I can see, is marked in either liter or milliliter. It is convenient to measure the volume of liquids in terms of liter or milliliter. So it is graduated in terms of in liter and milliliter, okay. Now see, when you pour a liquid in this beaker, say this beaker have marking on it. So if I say this is actually 0, okay, 0 ml, and then here you have 1 ml, okay, here you have 2 ml, okay, and here you have 3 ml. It's just an example. So we have taken a graduated beaker which have markings from 0 to 3 milliliter, okay, 0 to 3 milliliter. Now see, when I pour a liquid, okay, so I pour water in this beaker up to say the 2 milliliter mark, okay, so 2 milliliter mark. So I pour water up to here, so I pour water up to here, okay, so this is water, okay, so this is water. Now see, you have seen that when you try to insert a mug in a bucket full of water, what do you observe? The water splashes out of the bucket. A certain amount of water is just overflown, okay. So basically we utilize this property in order to determine the volume of that particular substance. That is a particular principle acting behind this. We will discuss that principle later on. For now, you just understand. Now when I want to measure the volume of a stone, say I with the help of a rope I tie the stone and slowly insert the stone into the water, okay. So we are slowly inserting the stone into the water. So here is a rope tied here, okay, I have a rope. Just let me clear the board so that it is easier for you to understand. I hope you have just copied all the informations mentioned on the board. Okay. Okay, so it's clear. Now see, we tie a stone, we tie the stone with the help of a string and slowly insert the stone into the water. Now when you are inserting the stone into the water, okay, what happens? Slowly the water level rises. Now this is the first figure, so just label it as figure 1. Okay, label it as a figure 1. So you can just sequentially observe the figure, so it will be helpful to you. So this is figure 1. Okay, I hope you have observed it carefully. What is happening here? We are just putting a stone into the beaker. Okay, now see the next figure. In the next figure, you can see what happens here is, as you insert the stone, when you have inserted the stone fully into the water, what happens? The water level rises. The water level rises. Say it rises up to this height. Okay, it rises up to this height. Okay, so now the water have risen up to a, see previously the water was here, now the water has level has risen. So this is our stone, so it has been inserted into the water with the help of a string. Now see, if I can just conclude from these markings that 2 milliliter and this is 3 milliliter, so the difference is 1 milliliter, and for those 1 milliliter gap you have actually 4 graduations. Okay, 4 markings. Now so I can actually divide that 1 milliliter gap into 5 segments. So this is 0.2, this is 0.2, this is 0.2, this is 0.2, and this is 0.2. Okay, so if I see this marking, this particular marking where the water is now, so I should mention it as figure 2, not figure 1. Okay, so this is figure 2. The next figure, we have inserted the stone in the water. Okay, so this figure, this particular marking shows us that it is actually 2.4 ml. 2.4 ml. Okay, so next only 2.6, next only 2.8, then it is 3 ml. So this is 2.4 ml. Okay, fine. Now previously the water was at, so I am just writing it, the first volume when the stone was not inserted. So volume, write it in bracket, stone not inserted. Okay, so let me just mention it as V1. Okay, V1, that was equals to 2 ml. Okay, now when you have inserted the stone, the volume of the water rises a bit. Now the volume, so this is first reading, this is your second reading. Volume stone is inserted. Okay, so stone is inserted. This is your volume V2. So V2 is equals to 2.4 ml. Okay, now see, so what will be the volume of your object that you have inserted? So I think it is, you are getting it a bit, so I can easily obtain the volume of that stone, this particular stone, by just subtracting these two volumes V1 and V2. So if I just subtract the volume, so I am just rubbing it off. I hope you have noted the figure. So this is your second figure, the previous one was figure 1, this is figure 2. There is difference, don't just overlook it. There is difference in the figure. Previously the water was at 2 milliliter mark, so that is why I have written V1 as equals to 2 milliliter. Next, after that V2 becomes 2.4 milliliter. Okay, so just I am rubbing it off now. So now we can come to the mathematical calculations. So how can you actually find the volume of the stone? So for finding the volume of the stone, therefore the third step is volume of the stone is given by the difference V2 minus V1, so it will be 2.4 minus 2 ml, and so it will be equals to 0.4 ml. Okay, clear? So this is the volume of your stone. So I think the calculation is quite clear to you all now, and this method can be used to determine the volume of any irregular solid. Obviously there is one factor to be kept in mind, that your object should be actually it should not actually float in water, it has to sink in water. If you are trying to measure the mass of any volume of any object which does not sink in water, then the process becomes a bit more lengthy, okay. First of all, just conclude this part, that we have, in order to determine the volume of an irregular solid like a stone, we have taken a graduated beaker, or it may be a graduated cylinder also. You first observe the volume of water when the stone is not inserted, then you just slowly insert the stone or just sink the stone in the water. Definitely there will be a rise of level of the water. The water level, when it rises, will give you the volume of the water plus volume of the stone. So in order to get the volume of the stone, what you have to do, you have to subtract the volume V2 from the volume V1 from the volume V2. In this way you can get the volume of the stone, okay. So I think the process is clear. If you have just overlooked or just overheard any information, please, you may pause the video, you may move back and watch whatever point you have missed out. So this is the advantage of this platform of learning. You can actually see the lecture as many times as you want, at whatever speed also you want. You may, if you think that the lecture is bit slow, you are actually feeling it very slow, then you can obviously just go to the settings and change the speed of the player to either say 1.5 or 2x also, and so you will have a video which is moving about very fast, so you will be able to cover the lecture in less time, okay. And those who are not feeling so bored, you can watch the video at this pace also, okay. So now let us see. I have mentioned that there is one factor you have to keep in mind, whether the object is sinking in water or not. If your object is not sinking, then you have to use a different technique. What different technique? Okay, say I want to measure the volume of a cork. What is cork? You all have seen cork. I think you are not totally unaware of this material, cork. As an example, I can say that sometimes in the glass bottles there is a brown color stopper. That is, I think you have taken that material in that hand. It is not plastic, it is not metal, it is a bit you can feel a wood like property, okay. So that is cork. You can see that in some glass bottles it is used as a stopper, okay, as a cap rather, I should say. So now if you want to measure a piece of say cork, it is an irregular shaped cork, okay. So like this you have, say okay, like this you have a cork, okay. So this is an irregular shape, you don't have any regular shape. If you had a regular shaped cork, then you may had applied the formulas that we learned in the previous classes, but this is not the case. So let us see how we can measure the volume of this cork. Now the cork, what is the problem with this cork? The cork does not sink in water, it remains floated, so it's difficult. So how we can measure the volume? Okay, for this we have to take another stone, okay, another stone. So say this is the black color is the stone, okay. So remember, blue color is the cork, black color is the stone, okay, fine. Now see what we will do. We will here take 3 readings, okay. We will here take 3 readings. So just let us move on to the demonstration, okay. So just remember, blue color means cork and the black color means is the stone, okay. Okay, now see, when you want to measure the volume of this cork, first of all you have to again take a graduated beaker. So this is a graduated beaker, okay, graduated beaker, and you have markings on it, okay. So you have markings on it. So say this is your rather this is your 0, okay. Now then this is your 1, okay, this is 1, then there is a gap, then again this is your 2, then there is a gap, then there's again this is 3, gap, so this is 4, gap, this is 5, okay. So this is your graduated beaker, okay. So it is marked in milliliter, so all these are in milliliter, okay. I think it is clear to you. This is in milliliter. So this is 0, this is 0.5, this is 1, this is 1.5, this is 2, this is 2.5, this is 3, this is 3.5, this is 4, this is 4.5, and this is 5 ml. So all these are in milliliter, okay. The beaker is being marked in milliliter, okay. So remember it, these are all marked in milliliter. So your readings are in milliliter, okay, fine. Now see, first of all we take water, okay, we take water, say we have filled the beaker up to 2 ml with water. So this dotted figure represents water, okay. So your first observation, so I can mention it as volume V1 is equals to, say you have taken 2 ml of water, okay, fine. Now when you are inserting the stone in this water, say with the help of the string, what you have done, you have inserted the stone, okay, you have inserted the stone. So this is a stone. When you have inserted the stone, definitely your volume of the water will rise. So I just see that the volume of the water now has risen to 3 milliliter, okay, 3 milliliter, fine, 3 milliliter. So let this volume be actually your second observation. So just mark it as V2 is equal to 3 milliliter, okay, fine. Now on the next step, what you will do, you will just pick up this stone again, and along with the stone, what will you do, you will tie the cork also. So just see, I am just easing it off, okay. Now I have inserted the stone, okay, and I have also tied that cork with it, okay. So like this was a shape, whatever it shape may be, okay, you have to tie the cork with it also, okay. So they are tied onto the same string, remember that they are tied onto the same string. So this is also has been just like this, okay. So and it has been wrapped around this also. So this has been tied on the same string. Now when you tie the string, insert the string with the cork and the stone both tied to it and just put it into the water, definitely your water level will further rise, okay, further rise. Now see, the water has risen up to a level of, say this is 3.5 milliliter, okay. So now this is your third observation. So your third observation is actually your volume 3 V3, this is your 3.5 ml, okay. Now so how can I say that, how can you measure the volume of this cork then? See, if I just subtract the I think you have noted down the observations, I am just rubbing it off. If you have not, please pause the video and note it, okay. So if I just want to determine, say when I subtract V2 minus V1, okay, when I subtract V2 minus V1, okay, so V2 minus V1, this actually gives you the volume of stone, So this is equal to how much? So 3 minus 2, 3 minus 2, that is equals to 1 milliliter. Okay. Again, if you subtract V3 minus V1, okay, so this gives you V3 minus V1 gives you, what does this give you? This gives you the volume of stone plus cork, okay, V3 minus V1. So this comes out to be, say rather, 3.5 minus 2, so it's 1.5 ml. Okay, so this 1.5 ml have both the cork and the stone. So what will be the volume of the cork? I think it is clear to you now. So volume of the cork is equal to, say, so you just subtract this 1 ml from this 1.5 ml, you will get the volume of the cork. So volume of the cork is 1.5 ml minus 1 ml, so it is equals to 0.5 ml. Okay, so this is your method for finding the volume of the cork. Okay, so I think in today's lecture it is very clear to you how you can measure the volume of irregular solids. In the previous lecture we have discussed about the technique used for measuring the volume of regular solids. We will end our lecture here. For the next part of your chapter or your syllabus, you must, I think you will be very eager to watch the next video. Before ending, I want to thank you all for supporting our channel, inspiring us to post more videos like this. Please do subscribe our channel, share our videos, watch our videos, and also please comment and press the bell icon so that you can get update about any other videos that are being uploaded. And please also mention your queries in the comment box, or you can mail us at the given mail ID. So till then, we will see you in the next class. Thank you. Okay, bye bye.